All right, so we're going to talk a little bit about something called infinitely many solutions, no solutions, and we've really talked a lot about one solution, and most equations have just one solution, and that's what we expect. But there are some special cases. So I like to bring back the balance beam because we think of equality as being a balance beam, and that's really important for when we're solving. Because what we do to one side of an equation, one side of the equal sign, we have to do to the other side as well. And I really want to pay attention to that concept. So if I have a balance beam and I want to, let's say, remove a block, it's okay because if we assume that they're balanced and I delete a block on one side, I delete a block on the other. And we really can start thinking about, hey, if I see a balance beam or an equation, I can assume that instantly it's true. And that's just kind of an assumption that mathematicians make. So we want to talk a little bit about one option here. If we start thinking, oh, I can remove a bag from each side. In fact, I can remove 2 bags from each side. Well, that's saying that really 3 blocks is equal to 6 blocks, and that's not really true. And so when we're solving equations, we're going to look for examples of that. So if we were to do this particular problem, this one would have an equation of 2x plus 3, because there's 2 bags and 3 blocks, and this side would have 2x plus 6. And we could subtract 3 from both sides. Or excuse me, what did we do? In this particular equation, we actually took away both bags, so we subtracted 2x from both sides. And then we got this weird thing, because 2x minus 2x is nothing, so I'm left with 3 equals, and 2x minus 2x, well, that's nothing, equals 6. And so this is something called a contradiction, and it means that there is no solution. I suppose it might be helpful to know that each bag contains blocks as well. So when we're solving these equations, we're going to go through 2 of them, and then we're going to give you an opportunity to try 2 of them as well. So let's take a look here. I'm looking for like terms, and so I'm going to first off combine like terms. So we've got 3x plus 4x, that's 7x, plus 5, is equal to 7x plus 5. Well, instantly I see here that, hey, like, there's something really cool going on. 7x plus 5 is definitely, most definitely, equal to 7x minus 5. And if I kept going, like, for example, I subtracted 5, and there's lots of things you could do here. If I kept going, I could see that, okay, 7x equals 7x. Well, that's also always a true statement. I could also say, oh, I want to divide both sides by 7, both sides by 7, so that I see that x equals x. Well, at any point in here, we had a lot of things that were true, and this would mean that there are infinitely many solutions. And that's really valuable because what it's saying here is that I can substitute x to be anything. Like it could be 2, or 3, or 1, or 0. And that's true. If x is 0, 3 times 0 is 0, plus 4 times 0 is 0. So that's 0 plus 5 is equal to, well, 7 times 0, 0 plus 5. 0 plus 5 is most definitely always equal to 0 plus 5. And we could do that if I wanted to substitute 1 there. 3 times 1, so 3 plus 4 times 1 is 4, so 7 plus 5 is 12, and 7 times 1 is 7, plus 5 is 12. So this is also always true. When I get something that is like blatantly obviously true, like x equals x, then we say that there are infinitely many solutions. Here's another example. So we'll go ahead and do this. And in class we learned that yeah, we could divide by 8, but here it's not really convenient to do that. So the couple of things that I'm going to do during this first step is I'm going to distribute that 8 inside the parenthesis, and then I'm also going to combine some like terms. So I've got like terms there as well. So 8 times y is 8y, 8 times 7 is 56, equals, and I'm going to combine the like terms, so 8y minus 8. Well, now I want to get the y's to the same side, so I'm going to subtract 8y from this side and subtract 8y from this side, and then I see 8y minus 8y is 0y, or just 0. and then the 56 is going to come for the ride. So 56 equals, oh, those cancel out too, equals negative 8. Well, this is a statement that is always false. And when we reach a point where we see that something is always false, we're going to call that no solution. Oops, sorry about that. No solution. And it's really important because what that means is that no matter what y I pick, there are no possible answers for what y could be that will make this equation true. So if I get to something that's obviously always false, we say that it has no solution. All right, I'm going to encourage you to pause the video and try these two problems out. Not only does it give you an opportunity to practice solving, but it also helps you practice identifying when something has a solution or no solution. So pause the video now. Magically, some work is going to pop up, and then I'll answer a question in just a few moments. So try these out before I do them, and then we'll get some main ideas. All right, and just like that, there's a lot to work with here. So if you take a look, I want you to just think for a moment which one is no solution and which one is infinitely many solutions. And go ahead and assign a label to those, and then I'll tell you what I'm thinking in just a moment. All right, so I see here that negative 30 equals negative 18, and I know that that's really never true. And so the answer here is no solution. And that's the answer. The answer is no solution. And I see here that 6 equals 6, and that's, to me, I think that's always a true statement. And so I'm going to say there are infinitely many solutions. Infinitely many solutions. And I'm going to abbreviate solutions, and your answer here is infinitely many solutions. I hope this video was valuable. Please make sure that you've taken notes and you have a record of those, because these could be helpful.